So before we get started with the actual presentation, I just want to welcome you all to the kickoff for the 12th Ocean of Data Challenge, AI in Action, featuring building bridges. And I would like to begin by acknowledging that we, in DeepSense at least, are currently located in Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. And this territory is covered by the treaties of peace and friendship. So we would like to acknowledge the Indigenous people whose traditional lands we're on today, and also ask that everyone take a moment to consider the territory in which they are situated in, as well as their own personal responsibility in the processes of reconciliation. So for tonight's agenda, we're going to start off by meeting the Ocean of Data team, then we'll do a challenge overview, we'll move on to our speaker presentations, give some more details about the challenge, and then finally we'll have a question and answer period. So we're going to get started now with an introduction to the Ocean of Data team. So the Ocean of Data team consists of 3 core organizations, DeepSense, COVE, and ShiftKey Labs. And then also for this specific challenge, we're partnering with Building Bridges, which is a collaboration between Dalhousie University, Ocean Networks Canada, CEUS, and also the Global Observatory of St. Lawrence. So I will start by introducing myself and my organization. So my name is Brogan, and I'm the Communications and Events Coordinator with DeepSense. And for those of you who don't know, DeepSense is an organization based in the Faculty of Computer Science at Dalhousie University, whose mission is to help grow the marine economy with artificial intelligence and machine learning. We are an enabling service-based organization and serve as a bridge between industry and the computer science talent pool. And what makes DeepSense really unique is our innovative model that places interns with ocean sector companies and provides them with expert support throughout their placement. So now I'll pass it over to Morgan if you want to introduce ShiftKey.
Hello, my name is Morgan Evans, and I'm the Events and Communications Coordinator for ShiftKey Labs. We're an organization that helps students and learners hone their tech skills across workshops and courses and events throughout Nova Scotia, and we are Atlantic Canadian based.
Awesome. And then our COVE representative, Sydney, is currently stuck in traffic, so she will be joining us a little later, and I'll let her introduce herself once she joins. So now for what all of you are here for, our challenge this semester is called AI in Action, and the challenge question that you will be tasked with addressing is how can AI be used to safeguard and support a healthy ocean ecosystem? So to give you a little bit of background on AI first, AI can help us better understand, analyze, and make use of ocean data by processing large, complex data sets quickly and accurately. It can detect patterns and trends like changes in ocean conditions and automate tasks such as image classification or data cleaning. This enables faster, smarter decision making across ocean research and industry. AI is applicable to many different ocean sectors. These are just a few of them. It can be applied to transportation and logistics, tourism, environmental monitoring and conservation, renewable energy, fisheries and aquaculture, and robotics and autonomous systems. And like I said, this is just some of the many ocean sectors that AI can apply to and that you could consider when you're thinking about your solution for this challenge. And although AI can work across many different ocean sectors, it can also work with many different data types. So this can include images and video, satellite data, acoustic data, text, genetics like eDNA, sensors like CTDs, and also time series data. And now you may be asking, why use AI for ocean data? And the answer is that it has several benefits, one of which is faster insights because it's able to rapidly produce terabytes of data uncovering trends in real time. It's also able to forecast ocean conditions, species migration, and climate impacts more accurately, and it can enhance detection. So it's able to identify patterns and anomalies like illegal fishing, oil spills, or coral bleaching before humans and traditional methods can. It's also able to help power underwater drones and robots for deep sea mapping, exploration, and data collection. And it allows policymakers and researchers and other stakeholders to use the AI generated insights to make informed, timely decisions for ocean health and sustainability. So it really helps to take our current methods, which are often time consuming and not very efficient, and it makes those faster, more efficient, and sometimes even more accurate to then allow us to use the information and the insights that we're gaining from AI in a more timely fashion. So with that, we're now going to move on to the speaker presentations. So during the speaker presentations, participants, you can feel free to send any questions that you may have for the speakers in the chat. After each speaker presents, we'll have a little Q&A session. So throughout, you can send them in the chat so that you remember them when the time comes at the end. So tonight we have two incredible speakers who have volunteered their time to share their experiences and insights with us. The first one is Ian Archibald, who is the Executive Director of DeepSense. And secondly, we have Shen Malloy, who is the Project Manager at Building Bridges. So Ian is going to start us off tonight with some examples of AI use cases in the ocean sector. And Ian is a seasoned entrepreneur and artificial intelligence strategist who specializes in the evolving landscape of emerging technologies. He was previously the CEO and co-founder of Swell Advantage, an ocean technology startup. He developed an innovative marine management software solution with this company. And Ian is a native of Nova Scotia who has a commitment to the natural environment and passion for building communities. So Ian, I'll let you take it away now.
Great, thanks, Morgan. Let me just share my screen here, folks. Okay, so just going to go real quickly through what DeepSense really does, or sort of from a structure standpoint. Brogan covered a lot of it, so I'll keep it brief. But the first thing that we do is provide a talent pipeline for the marine sector, introducing the next generation of machine learning and AI experts, that's you all, to the marine sector as a viable career path. The second thing that we do is we collaborate and work with partners to bring AI and specifically machine learning expertise to their organizations. So we work with organizations like CU's, Ocean Networks Canada, the Marine Institute, Coast, COVE, a wide variety of different enabling organizations to the sector to help them upskill with AI and produce new services and offerings. We work with a lot of established companies to deliver AI and machine learning projects. We generally do 4 different types of projects, and this is where you can go on our website, apply to be an intern, and we generally support 4-month internships. We can work with students from almost any university in Atlantic Canada. And we do machine learning readiness, so that's helping organizations develop data pipelines and labeling systems to leverage AI in the future. We do machine learning model development, so that's where we generally take proprietary information from a project partner, and then we're able to train a proprietary model and then hand that back to the organization. We've started doing machine learning audits. That's where we work with machine learning organizations that already have a strong machine learning capabilities. We'll do model assessments for integrity, efficiency, all kinds of different sort of views. We can look at bias, whatever the organization's concerned about. And then we've started getting into doing generative AI projects, whether that's developing RAG structures or training narrow models related to a specific offering. And then we also work with startups both to help them develop their AI-based strategies and to develop the models and structures that are often core to what they're delivering. So we'll start getting into the projects of it. And so there's a whale in this picture. And the question is, where is it? Now you probably want to say right in the middle of the picture there, but that's actually a boat. The whale in the picture is right there. I've been looking at this picture for a year now. I have trouble seeing it. If you really look hard and imagine, it might be there. But what these computer systems can do is they can recognize patterns that often we can't. So what we do is we take thousands of images. First, we develop a model that can select the photos that might have a whale in it. And then we comb through those pictures, label the pictures where the whale is, and then use a machine learning model or train a machine learning model with those labeled images to be able to provide that repeatable value. Another one is with video footage. We're able to classify different things on the boat. You can see here that it's identifying the different fish by type, by size, and also tracking the individuals on the boat. So there's all kinds of great things that we can do with video imaging and still images around identification and classification. Can also, of course, do that in the natural world. So the ability to see different types, identify different types of kelp or other economically or ecologically significant species. We've got a fun one right now, actually, where we're doing a project with the Marine Institute around reef balls. So in that one, we're going to be assessing reef balls for whether or not lobsters are making them a habitat. We're going to be analyzing the amount of sugar kelp growing on them, and then also analyzing the general biomass on the reef balls. So lots of ways to apply this to marine species and in the marine area. Now, you can also use these technologies to assist with man-built systems. We've done a lot of work with Glass Ocean. They do hybrid retrofit systems for inshore fishing boats. And we've done a number of projects with them. One is predicting power and emissions. They had their own sensor cluster that they were putting on boats. And they said, hey, can we use the sensors on people's phones to get a similar response? And we went in, we worked through it, developed some models, and we were able to get similar performance from people's phones, which, as you can imagine, it's a lot easier to download an app than it is to get sent a physical sensor cluster and putting it on your boat. We've also helped with anomaly detection. So basically, working on the power usage and efficiency between the electric system and the diesel system. And in this case, we actually found a problem with the diesel engine that needed some serious maintenance. So we developed a system that's able to essentially assess both systems on board and make recommendations accordingly. This is a really interesting one around tidal energy. So what this image is we have in the Bay of Fundy some of the strongest tides in the world, and they were trying to figure out where to put these tidal turbines. And when all this tide is running, the water actually naturally cavitates or forces air down. And if you can imagine, if you've got a turbine spinning, air will impact the efficiency of that turbine. So in this case, we have these graphs showing the turbulence being forced down by the tide. And people were painstakingly going through and highlighting by hand each area of turbulence so it could be analyzed. And we developed a model that could do that for people. So significantly reducing the number of people hours it would take to process this information and learn more about how the natural cavitation in the water would impact the ability to collect tide energy from the tides. Natural language processing is another application that can be used in the marine space. In this case, we were looking at ship manifests, mostly looking for mistakes, so anomaly detection, mostly around fraud. So the idea that people would maybe fudge the numbers or move a decimal place and say, oh, it's a mistake. But in many cases, you can see the pattern of people doing that, and those are no longer mistakes. That's now fraud. This is a really fun one. So using natural animals and watching the natural environment to detect water quality. So in this case, we were working with a company that mounted these bivalves. In this case, we're talking about mussels. They also did it with oysters. And bivalves feed by filtering through the water. So if something's wrong in the water, they'll close up really quickly. And how healthy they're or how much they're feeding can directly represent how much or how sort of what the water quality is. Really fun project, and a good example of how we can use use these in natural systems. Shipping logistics. So we've done a lot of work with the Port of Halifax to figure out various things around logistics. One of the coolest ones is we developed a redundancy system for the weather buoys at the mouth of the harbor. There's 3 different buoys, and basically the pilots, so when a ship comes into harbor, a special captain basically goes out, meets the ship, climbs on board, and helps navigate into the harbor. Each harbor is different, and this is a way that we stop a lot of accidents with these massive container and other ships that come in and out of the harbor. Now, if the conditions are too rough, the pilots can't get on and off the boat safely, and then shipping gets backed up or what have you. So what we help do is we use machine learning to say, as long as we have 2 of the buoys working, we can extrapolate what the conditions are going to be at the other buoy. So in the past, if one of the buoys went down and there was any hint of rough conditions, they'd have to basically stop ships coming in and out of the harbor. Now with this system, we can sort of extrapolate what the conditions are like, where the pilots are going to get on and off the boat. Excuse me, and we're able to give them the information they need to keep doing their jobs. Another really cool one that we're working on right now is when a ship passes under a bridge, it's called an air gap, the gap between the tallest point of the ship and the lowest point of the bridge. Now, some scientists, when they were doing some work around carbon sequestering, discovered a bit of an anomaly slosh in the harbor that hadn't been seen before. And there's a concern that if everything goes wrong and this sort of slosh happens when a boat is traversing under the bridge, it could lead to less air gap than they think, which would be a safety concern. So we're currently helping to model out exactly what these sort of sloshes are and help them ensure safety around the air gap under the McDonald Bridge here in Halifax. This is a really fun one here. We're working with a BC startup. We help them develop a model that can identify plastics on a coastal environment from drone footage. So especially out west where they had the Japanese tsunami, which sent all of this trash over to the west coast. And this model helps OceanAid identify where those plastics are so they can do beach cleanup. And it's really cool, actually. The first pilot that they did late last year was with an indigenous community who wanted to know essentially where all the trash was in their territory so that they could go out, start going out and taking care of it in an efficient manner. Did another one here with a Nova C. So this is looking for, on sonar footage. They were like, can we take sonar footage and basically treat it like normal images? And we were able to do detection of different objects from sonar. There's another cool one. We've done a lot of work with the Nova Sea. So in this one, basically what was happening is you had these hydro dams, which are a really important part of clean renewable energy, but they were chewing up fish at certain times of the year. And so they had to install these sort of fish ladders, and it actually allows the counting and detection of fish going up and down these fish ladders. So now we're able to count and understand how these facilities are impacting fish, and they're able to stay open quite a bit longer because of it. This is a really fun one that we did with an overseas. So what happens in aquaculture pens when there's too much fish poop and food is that it adds too much nitrogen to the water and you get algae blooms. You know, these little microscopic plants that'll bloom and they cut the oxygen out of the water. So what we were able to do is they said, hey, we've got all this data about oxygen levels in aquaculture pens. Could you build a model that would predict when we're going to get to one of these critical moments where the oxygen is too low and the fish start dying? Because you can't see how much oxygen's in the air, or I mean, sorry, in the water. So what they can do then, it's pretty cool. They can just back their boats up to the pens and aerate the pens, move the entire pens in some cases, or take the fish out of the pen. So we worked it through a few different models, sort of testing different scenarios. And we were able to get a model that was about 48 hours in advance, i.e. we could predict the oxygen levels in these pens 48 hours in advance. We gave it back to the company. They actually took it, got it to 72 hours in advance, productized it, and they're now selling that in market to aquaculture companies. So there's all kinds of different ways that we can apply AI in the ocean space. There's some really cool stuff happening with generative AI as well. I don't know if the video that we saw of the fishing boat there with the tuna and other fish, that company's actually gone on and they're using generative AI to build a general classification system that will be able to classify marine animals in real time from live footage using generative AI. So there's all kinds of super cool and interesting ways that you can apply machine learning or generative AI to the ocean space. In some cases, there's even enough data to do deep learning. So lots of opportunity here, and it'll be really exciting to see what everybody comes up with.
Great, thank you, Ian. Do any of the participants have any questions for Ian before he leaves?
I don't see any right now, but if anyone wants a second to write up a question for Ian, this is your chance.
There's a hand
There's
up
none in
there.
the chat.
Oh,
No, nothing yet. I don't think. Can any other participants like voice chat in this one, or is this just a panel? Oh.
okay. Well, you can all, follow up with questions if you'd like. And again, if you're interested in doing a DeepSense project, please apply for the internship through our website. We have all kinds of really fun stuff to work on. Thank you. Nope.
We do have a question.
Oh.
So Ian, what are 2 to 3 top challenges you are currently trying to solve that has not been looked at with AI in the ocean?
Oh, wow. That's a brutally hard question. My goodness. Maybe you should be a lawyer. No, sorry. Yeah, that's tough. I think that, one thing that's really interesting that's happening right now in the ocean is we do have a lot of data collection, but it's such a vast area. There's all these gaps. And one of the ways, or one of the great uses for generative AI is to create synthetic data. So similar to kind of what we're doing, or we did with that weather buoy of a redundancy system, is we're essentially filling in, that area, or predicting what the weather is going to be in that area. And there's a lot of I don't know how many people are doing it, but one area is sort of filling in the gap using generative AI to create synthetic data that fills in the gaps between real data. So that'll help with modeling, things like that. Also, that just sort of general modeling the ocean, that old analogy of, a butterfly flaps its wing in Japan and you get a hurricane in North America or a typhoon in North America. Like the weather is so complex. And generative AI gives us the potential of creating really complex models. I think the EU is putting something like $500 million into just developing a new generative AI based model of our oceans. And, with climate change, there is no really baseline or normal anymore. We've worked with one company who said that, they're harvesting fish, and it used to be an anomaly year once every 10 years. But now an anomaly is every 2 or 3 years. So essentially every year is an anomaly now. The idea of baseline is really tough, and we need to develop systems that, as our climate's actively changing, systems that can adapt and do predictions, maybe not on the longer time horizon like we've been able to in the past, but in shorter time horizons, and deal with that complexity, deal with the changing nature of our environment. So I think sort of the maybe the top challenge is climate change, and how do we adapt, and how will our systems, we're talking about like the North Atlantic current right now slowing down or even reversing, which could have huge implications for the global economy. It could make big parts of Europe unlivable. So I think climate change would be the top challenge that we're trying to solve. And a lot of it hasn't been looked at yet because it's an evolving situation, and we're just figuring out sort of a lot of generative AI technologies and what have you at the same time that these changes are happening.
Awesome. Thank you, Ian. I think that's all the questions we have.
Cool.
Okay, perfect. Well, thank you again for joining us tonight, Ian. And now we're going to move on here. Wait, I will just re-share my screen here. So now we are going to move on to Shen, who will introduce building bridges and demonstrate the CU's data portal. And in her role, Shen oversees activities, progress, and deliverables, and coordinates between project partners, funders, and stakeholders in the ocean community. As an early career ocean professional, Shen is particularly interested in the impacts of climate change on the natural and anthropogenic world, strategies that can be implemented to better manage and conserve these ecosystems, and how to best educate and advocate for sustainable practices. Shen has a Bachelor of Science from Mount Allison University and a Master of Resource and Environmental Management from Dalhousie University. So now I will turn it over to you, Shen.
Perfect. Thanks, Brogan. Let me just share my screen here. We good?
Yep,
Yeah.
you're good.
Okay, awesome. Yeah, great. Thanks for that intro. You basically said it all. I can basically just dive right in. So yeah, hi everybody. Thanks for having me. I'm here today to talk a little bit about ocean data management, in particular in this new era of artificial intelligence. So before I begin, I just would like to acknowledge and respect the First Nations, Métis, and Inuit peoples on whose traditional territories CU's work is conducted. We strive for respectful relationships with all Indigenous peoples as we search for collective healing, true reconciliation, and honoring these beautiful lands and seas together. I am currently on Jabuktuk, otherwise known as Halifax, the unceded and traditional territory of the Mi'kmaq. Okay, so first up, the Canadian Integrated Ocean Observing System, or CEOS, as it's otherwise known as. Basically, it is an online platform for sharing, discovering, and accessing ocean data across Canada. We first launched back in 2019. And CEUS basically supports ocean research by making connections that generate information and place-based knowledge to advance ocean health and the blue economy and coastal communities. So to kick things off, I just want to set the stage here for why CEUS was established in the first place. So data management is often overlooked, but it is incredibly important. With all of these modern advances in technologies, we've had a very quickly moved from a time of data scarcity to a time of data plenty. Obviously, these advances give us the ability to collect incredible amounts of data in real time on a daily or even hourly basis, and this allows researchers to make more informed decisions. So when considering ocean data across Canada, you can imagine the vast amounts of data that is being collected across all the various sectors. There's project-based work, operational monitoring, regulatory requirements, strategic decisions. But the problem is a lot of this data is used in isolation or for a limited amount of time. Data is often used by the source organization and then shelved or stored with no ability for it to be potentially discovered and used down the road. I've certainly been guilty of this. I'm sure others have too. But there is minimal long-term value when doing this, and it often leads to duplication of efforts simply just because there's a lack of awareness of what is actually out there. So clearly there needed to be some sort of coordinated system that brings together Canadian and international observing data that is openly accessible to the public. And so to achieve this, we needed to establish some best practices for managing all of this data that can accommodate, the variety of needs from all the broad range of stakeholders. So this is where the FAIR and CARE data principles come in. And these are national standards that CEUS is built upon. So FAIR stands for findable, accessible, interoperable, and reusable. So this basically means that FAIR data is data that is discoverable, that is openly and freely available in an internationally agreed upon format with specific naming conventions that can be understood by all stakeholders. So the FAIR principles primarily focus on open data sharing, but they do ignore historical context. And this is something that we see a lot in Canada, particularly the idea of data sharing can create tensions for Indigenous communities who rightfully should have control over how their data is used and how their traditional knowledge is used. So this is where the CARE principles for Indigenous data governance come in. So CARE stands for collective benefit, authority to control, responsibility, and ethics. And the CARE principles are more people and purpose oriented, allowing data to better support and reflect Indigenous innovation, their views, and supporting the reclamation. So the FAIR principles and CARE principles go hand in hand and really encourage scientists to consider both people and purpose in their research. So now moving on to how CEUS actually works. So this is a diagram that highlights CEUS's structure and connection across Canada. We have 3 regional associations, CEUS Pacific, the St. Lawrence Global Observatory, and then us out here, CEUS Atlantic. And then each regional association is operated by local partners. So for example, CEUS Atlantic, we are operated by Dalhousie and Memorial University in Newfoundland. We're also in the process of establishing a national coordinating office, and we also often collaborate with the Arctic and Great Lakes observing systems just so we can properly capture a holistic view of Canada's ocean data. So basically, CEUS is designed so that data that's integrated into our system is visible both regionally and nationally. So the more data that is shared, the more robust we can make our catalog for data users. And so this bottom-up approach pretty much ensures that CEUS will continue to be connected and responsive to the needs of the local regional stakeholders while still maintaining a consistent national approach to data quality and standards. So here's a little bit more nitty-gritty. So we have a team of engagement specialists that work with the regional data contributors. So industry, municipalities, federal, provincial governments, universities, nonprofits, basically anybody you can think of who does ocean research. We're like, yes, give us your data so we can have it and store it and use it. So once we get the data, our CU's technical team then uses the shared data to create tools and visualizations that basically enable the discovery and access of your ocean data. So as a data provider, you will be able to further increase the recognition of your work and further validate your data. And then as a data user, you have access to multiple sources of coastal and ocean data that can ideally help you fill gaps and help you see the bigger picture of whatever you're working on. So now zooming out internationally here, you can see that Canada is actually part of a global ocean observing system. So centralizing all these repositories into one international framework greatly increases the possibilities for ocean data that would have otherwise been hidden from anybody who wasn't directly involved in that research. So it's really a global initiative that's working towards a future where ocean data is widely available and well utilized for sustainable ocean health and economic growth. So CUS has two main data exploration tools for searching and downloading data sets. The Data Explorer is a map-based application that allows you to search geographically across data sets, and then you can download it from there. And then the data catalog allows you to filter and search the full archive of CU's data in its original format. And I'll do a live demo on both of these in the second part of this presentation. But first, I need to talk about building bridges. So Building Bridges is a specially funded project undertaken by CUS and a couple of our regional partners to increase the adoption of artificial intelligence in the ocean sector with a particular focus on non-for-profits. And this includes everything along the AI pipeline, from identifying opportunities to actually developing and deploying an AI model. And with this project, we really want to develop the tools and the resources so that organizations can really take advantage of the opportunities and the value that is provided by AI. So we started by talking with people and organizations in the ocean sector, basically just to see what is working, what doesn't work, what are the gaps and the needs and the challenges, what makes it easier for you to work with AI if you are currently, or what has stopped you from working with AI. And then based off of that needs assessment, we have several activities planned, workshops and community events like this Ocean of Data Challenge, just to help build that community of practice and connect ocean people to talk about the opportunities with AI. We're also developing learning resources and free online training, the first of which will be available later this month, as well as actual proof of concept AI models and visualizations to demonstrate the potential AI applications of that are currently being used in the ocean sector. So here's a little bit more of a breakdown of what each individual partner is working on. So Dalhousie is mainly responsible for, I'll say, establishing the baseline knowledge for AI in the ocean sector. So as I said, we're creating free training courses to help address the needs and the gaps that we identified during the requirements analysis period. So we'll be looking at what information or what skills that were most useful for nonprofits to take advantage of AI. And as part of those training materials, we'll also be publishing some case studies. So these will be analyses of specific AI models being used externally, not within CUS, in the ocean sector, and their associated work and benefits. The first of which will be highlighting an organization called Whale Seeker, which is based in Montreal. And they're using AI models to track whales and other marine mammals in the Gulf of St. Lawrence. So some cool stuff coming out of there. Speaking of the St. Lawrence, as we're going east to west here, the St. Lawrence Global Observatory, their primary focus in this project is actually integrating AI into the CUS infrastructure, just to help streamline and automate some of our internal functions and hopefully make CUS a little bit more user-friendly. Since data is such an important part of an AI model, you need to really ensure that your data is accurate, because if you put bad data in, you're just going to get bad data out. So we're creating a data cleaning tool to help with that quality control. And there will also be some work done for annotating data sets by implementing persistent identifiers and knowledge graphs so that data can be used for AI model training and validation. And this will basically help people find related data sets within the CEUS catalog that are AI ready if you want to use it for a model. Next is Ocean Networks Canada, which is part of the University of Victoria out in British Columbia. They are creating an AI model to identify anomalies in hydrophone data. So data can often have outliers due to gaps, just straight up instrumentation failures. So this model will essentially help identify and fill those gaps so that you'll have a more complete data set for your analysis. And then lastly is the Hackeye Institute, also out in British Columbia. They have created an AI model to map mussels using drone footage. And now this model is being extended to other variables, including kelp forests and barnacles. So just an example of how AI can be applicable to a wide variety of, I mean, this is what we've been talking about all day. So you guys get it. So I just want to highlight a little bit more in depth some of these AI models just to give you a bit more context on how they're actually being built. So first, this is the data interpolation and reconstruction work package. Realistically, when we're out in the field, ocean data is rarely uniform. Gap filling and error correction is a very, very common step for preparing data for AI applications or just normal modeling. So using this water quality data set from CMAR as an example, this is a multi-year data set that collects temperature and dissolved oxygen data at various stations and depths across Nova Scotia. And so you can see this, I don't know if you can see my mouse. Yeah, it's okay. So the plot in the middle basically shows gaps. If you can see in the dissolved oxygen record, you'll also notice it's clipped the data above 120% and below 85% saturation. So what do we do to fill this in? Since this is a time series data set that has uniform high frequency data sampling, basically we artificially create a test data set that has non-uniform sampling frequency using sensors from the CMAR data set that we know we have. And then we label those features for time and depth and sensor type, basically to create a machine learning model that's run over and over again so it can identify useful patterns and then ideally fill in that missing data. Next, I want to highlight quickly here Hackeye's mussel mapping models, just because we all love drones. So basically, they have a fleet of drones that they're flying over the British Columbia coast, and they collect image data in a grid pattern, which is then integrated into a software to convert the imagery into a 3D model. And then to train the model, we use this thing called semantic segmentation. So we have a large number of images, and basically what we do is pair them with a matching grayscaled image with black and white labels where mussels are located in white and where they're not located in black. And basically just put them on top of each other and train the model on 1,000 of these different images and then use that output to analyze and measure where mussel habitats are located, which is kind of cool. Okay, the last thing I wanted to touch on before I give you a little tour through the CEUS website is AI literacy. At CEUS, we have an unofficial tagline that we try to follow when building applications and models, which is adopt when possible, adapt when necessary, and develop as a last resort. So this basically means that AI models require a lot of time and resources, both computational resources, but also environmental resources, right? So if something already exists out there that addresses your problem, then we should be doing our due diligence to leverage that existing knowledge. Basically, we want to be using AI responsibly, so I encourage you all to think critically and creatively about how you're using AI for this challenge, but also in your daily life. Just some food for thought for you. Okay, now I'm going to switch over here to CEUS.ca. I think this is still work. I'm also like fiddling around with the Zoom like face thing. It's kind of covering half my screen, but we'll work with it. So this is what the homepage looks like, basically just cus.ca. And we have our two main data exploration tools right here on the front page for you, the Data Explorer and the Data Catalog. So I already loaded it in another tab. But this is what it looks like. It's basically a click and drag situation. The data points you can see them all across Canada. Basically, the darker the color, the denser the data points in that specific region. So let's zoom in here to Nova Scotia, since I assume this is where most of the people are joining from. Give it a second here to render. So once you get into a more local scale, you can see that it is giving you more information about the type of platform that the data was collected in, and the size of the dot essentially represents the size of the data set. So up here, you also have the option to filter and search if you're looking for a specific ocean variable. You can turn off and turn on whatever you're looking for. Ooh. And then you can also, if you want to, filter by type of platform, the contributing organization. Say you're only interested in government data, you can only click Fisheries and Oceans Canada. We also have stuff from COVE and ECCC and a variety of different data contributors. Next, if you know the specific name of the data set you're looking for, you can do that. I feel like this is going to be less relevant. And then if you're looking for like a specific season or a specific month, you can filter for that as well. So what happens when you actually click on a data set, right? So this will pop up a sidebar menu here that will basically give you the title of the data set, what the source organization was. So for example, this one is Fisheries and Oceans Canada. It'll give you the ocean variable that is associated with that data set, and then the links off to the data catalog and ERDAP, which is how you actually download the data. So let's see if we can find a good example here in Halifax. All right, so let's use this one, Halifax Ocean Terminal. So if I click on the CCAN button, so this takes us to the actual data catalog. So this is what you'll find if you like search the data catalog way, but we just went through the Data Explorer way because I like it more. So it'll basically give you a brief description here about the data set, what licenses it's attributed with. All of these are open licenses, so you're free to use and share to your heart's desire. A citation if you need it for a specific reason, if you're writing a report or something, some keywords, and then here's a bit more of the metadata aspect of it. So metadata is data about the data. So when was it collected? How was it collected? Who was it collected by? And some contact information if you need it. But how to actually download the data, we use this thing called ERDAP, which is basically a tool to splice and dice exactly what you're looking for in the data. So a lot of these data sets are very, very big, and they go back a couple decades. And you might not be interested in all of that jazz. It can be very overwhelming. So this basically allows you to download exactly what you want. So let's say you're only interested in air temperatures. You can just click that button, hit submit, and it will give you all of the data for that specific variable. But you can also, what's really particularly special about this ERDAP function is that you can put constraints on the data. So let's say you only want air temperatures from 0 to 30 in the positive range, right? So I can put that in, click submit, and it will give me all of the positive degrees. So that's a really easy, quick example of how you use this. And then all of these values down the side here are basically just like the max and min values of each associated variable. Does that make sense? So I will show you this again through the CU's catalog version. So here back on the home screen, instead of clicking Data Explorer, we can click on the Data Catalog. I also have it open over here. So this is what it looks like. We have 2,620 data sets for you to peruse. You can search by keyword if you know specifically what you're looking for, temperature, current, salinity, etc. Or you can scroll down here and search by specific ocean variable. So either way will work. Let's try surface currents. So this will basically bring you up all of the surface current data that we have across CU. So again, here, it's basically just like a Google search. It will list all of the relevant data sets. You can put additional variables if you want, surface currents plus oxygen, and it will give you a more specific search for that. Again, this is all the filtering stuff along the side here. You can filter by data contributor, you can filter by what region you want it to be in, et cetera, et cetera. So let's click on this top one here. And yeah, so basically they all look like this. Title of your data set, your description, and all of the metadata that is associated with that particular data set. So does anyone have any questions about downloading data? It can be a little bit overwhelming. Here's a good point. I will point out, we do have a CU's YouTube channel, and on this, down here, we have a video, a much more in-depth, detailed version of how you can access CU's data through ERDAP. So that would be a really great resource to use if you ever get stuck. It can be a little bit overwhelming to use at the beginning, but is a very handy tool. Yeah, I can stop sharing there. Hopefully that made sense. It was a little bit quick, but
Awesome. No, thank you, Shen. If anyone has any questions, feel free to put it in the chat like we did for Ian. We'll kind of give it one more minute. And if not, would we be able to share your information, Shen? Your email?
Oh, yeah, absolutely, for sure, yes.
Amazing.
I can also put that link to the YouTube video that Shen was showing. I can add it into the challenge document so you all can have access to it and easily find it as well.
Perfect.
Yeah, I'll drop the link in the chat right now too.
Awesome.
Yeah, and on that YouTube channel, we also have recordings of previous webinars that we've done for building bridges. So you'll get a much more detailed version of some of the stuff that our partners are working on, the muscle mapping stuff, the anomalies with hydrophone data stuff. Obviously, I'm not directly making those codes, so those tech guys can really break it down for you if you're interested in how that works. But yeah.
Well, I don't see anything else, so thank you so much, Shen. That was awesome.
Happy to be here.
How are we going to find our join team? We'll cover that in the rules. Brogan will answer that. I can't hear you, Brogan. But someone asked how are we going to find or join a team?
Oh, okay. So if you want, you can send messages like in the chat, seeing if anyone else is looking for team members. Otherwise, if you have like friends or people in your field of study that you're interested in, maybe in your classes, you could talk to them. But if you're looking for people who are already interested and already like signed up but don't maybe have a team, you can facilitate that in the chat if you would like. So I will say thank you again to Ian and Shen for joining us this evening. It's been a pleasure hearing Ian's insights on AI and its importance, as well as learning from Shen about building bridges and the CO's data portal. So we truly appreciate your time and contribution to the challenge. And before we move into getting into some more of the details of the challenge, I'm going to throw it over to Sydney because I know she didn't have a chance to introduce COVE at the beginning, so she can talk a little bit about COVE now.
Thank you, Brogan. I was on the way back from Lunenburg for an event, so I was late. COVE is an innovation and technology hub that is focusing on helping other organizations create and refine their marine technology so that they can either bring it to market and commercialization, or so they can use it for research. My main thing that I do at COVE is workforce development. So my job is helping get people interested in working in the oceans industry, and a big part of that is an internship program. So if anyone is interested in ocean data or anything like this, the internships for next summer will go up in January, and we may be doing internships in the fall and winter. So I always like to plug the internships whenever I get to go. So hopefully that's everything we were looking for.
Awesome. Thank you, Sydney. So now I mentioned previously that the overarching challenge question is how can AI be used to safeguard and support a healthy ocean ecosystem? But the challenge is actually divided into 3 streams, which are ocean economy, ocean environment, and ocean society. So the first stream is ocean economy, and this stream focuses on how AI can accelerate innovation and sustainability in ocean-based industries such as fisheries, aquaculture, shipping, tourism, and offshore energy. And participants will explore real-world challenges like improving fuel efficiency, optimizing supply chains, or using sensor data to enhance aquaculture operations. And the goal of this stream is to apply AI in ways that can boost economic performance while also reducing environmental impacts and helping marine sectors thrive in a changing world. The second stream is ocean environment, and this stream focuses on applying AI to understand, monitor, and protect ocean ecosystems. Participants will work with environmental data sets such as satellite imagery, acoustic data, and sensor readings to detect shifts in water quality, model species distributions, or identify early warning signs of ecological change. Projects might include using computer vision to analyze kelp bed health or machine learning to track marine biodiversity. And the goal of this stream is to develop AI-powered solutions that support conservation, promote climate resilience, and enable sustainable resource use. And then the third and final stream is ocean society. And this stream highlights the intersection of ocean data, AI, and human communities. So participants will explore how AI can support coastal resilience planning, integrate indigenous knowledge systems, improve equitable access to marine data, and promote ocean literacy. Projects could include tools for flood risk prediction, community mapping of marine resources, or inclusive data platforms. And the focus is to create AI-driven insights and solutions that are socially responsible, culturally relevant, and designed to serve the people and the policies connected to the ocean. So for this next part of the presentation, I'm going to pass it over to Morgan, who will talk about some more details of the challenge.
Hello. So we have a couple of challenge rules to go over. So yeah. So the first one is competitors must enter their own, either own the rights to all software used in their project or have written permission from the owner. So we don't want any copyright infringement. The second is that submissions can range from chatbots to classification models. So it's really whatever you want. We like to be surprised. And then the third one is competitors can participate individually or in teams of up to 5 members. The fourth is that submissions must not include any confidential information. The fifth is that each project must be based on data from the CEOS data portal, with the source clearly cited in the presentation, infographic, visual, or slides. And additional supplementary data sources can be used. The next is that competitors must currently live in Canada and have an active Canadian bank account so we can pay you if you win. And then the last is that competitors must be a current part-time or full-time student at a post-secondary institution in Canada or have graduated from one of these institutions within the past 12 months. And then the final submissions section is that and this is quite important, is that in order to be eligible to win, every team member must complete the team member registration form. This is different than the ticket tailor registration you filled out to attend this kickoff. The team member registration is a Google form, which you can find the link to in the challenge description document and on the Ocean of Data page on the DeepSense website. One team member must then submit the team concept submission form and the link to your record video presentation to info@deepsense.ca. If you have any additional support materials, feel free to share them as well. And then you must present your idea in a video that could be shared with judges. In this challenge, there will be no live presentation, just the recorded video. The video must be no longer than 3 minutes, so be sure to edit or refilm as needed to stay within the time limit. The video must be uploaded online, preferably as a private YouTube link. Any videos that need to be downloaded to be viewed will not be accepted. Feel free to use any format you like for the video. We will accept a direct pitch to the camera, a narrated slideshow, or anything else you might come up with. I know there's a lot of information to take in, so don't worry, we will send you all the details in the email. Throughout the challenge, if you have any questions about the submission requirements or anything else, please send an email to info@deepsense.ca. And next, I am going to hand off the next set of slides to Maggie, who's our ShiftKey ambassador.
Hello, everyone. Prizes, which you've all been waiting for, I'm sure. So I guess we're going to get started with them. So how the submissions are judged, they are evaluated on several key factors, including design, completeness of solution, difficulty, like technical difficulty, origin and creativity, clarity of presentation, and overall usefulness or potential impact, whether it's in a business setting or for a broader social good. So focus on the challenge streams. In the past, creativity has definitely been a big factor in it. There's also past winners on the DeepSense website if you want to use that as a resource to kind of veer yourself in the right direction. The first place prize is 500, and you can see how the rest will follow. The best presentation award will be presented later on in the summer at the showcase, the Ocean of Data Challenge showcase. That is going to be explained later. So this is the challenge schedule, the events that lead up to the showcase. Today is the kickoff. Everything here has been recorded, so if you have a friend or missed any information, like Morgan said, we will send out all of the information. And then you have about 2 weeks of silence to work on your submissions before they're due. Before that time, anyone can join. So if you have a friend that you might want to do it with you, as long as they fill out the team registration before then, you're good to go. The 18th to the 27th, the judges will review the submissions and select winners. And then on the 3rd, winners are announced. And July 7th, like I mentioned earlier, is the Ocean of Data Challenge Showcase, where you will have the opportunity to present your slides again, or your whatever your submission was, to our industry professionals and panelists. And that is where the best presentation showcase will be voted on by participants. And I'd like to open the floor to any questions. You can just drop them in the chat. Oh, I think we're seeing
Someone wants to know if there are any potential job opportunities for the winners.
I think that
or
I'll
Meg,
let you answer
go
this one,
ahead.
Morgan.
Okay, I can kind of touch on that. I'm not sure if people will come specifically with job opportunities, but I know at least when we're looking for potential interns for DeepSense, like personal projects that they have and any type of experience where we actually get to hear from them and see what they're capable of is a great enticing factor for us when we are looking for our future interns. And there definitely could be people from industry who are currently hiring and looking for it, but I can't guarantee that there are people who will be using it as a chance to scope out future talent.
I can kind of touch on that too, Brogan, that when we are looking at applications for internships, doing personal projects like this will really help you stand out against someone else who has all the exact same qualifications that you have. But if you have something like this, it really shows that you take initiative and can do your own side projects and show that you're passionate, and that can really, really give you that edge that you need when looking for a job. Awesome. I think that's all for questions in the chat.
Yeah, if there are no more questions, I just want to thank you all for joining tonight on the evening, and we really appreciate you taking the time to be here with us. And if you have any questions throughout the challenge, feel free to email us. We're happy to help and be involved. So I hope you all have a great rest of your evening, and I look forward to seeing your submissions.